We're going to go through example 4.3 now. This is in your textbook. It's asking to find the concentration of chloroform, which is a carcinogen, CHCl3, in drinking water. That would result in a 1 in a million risk for an average person, 70 kilogram adult, who drinks 2 liters per day throughout his or her entire lifetime. Okay, so these are kind of standard values. All right, we know that the cancer risk that we are trying to find out what concentration would meet that. That's the 1 in a million risk that we're willing to accept, or 10 to the negative 6. So risk equals the CDI, the intake, chronic daily intake, times potency factor. So how much you take in of a certain concentration times how potent it is, right? Okay, potency factor for chloroform is in table 4.9, and you can look that up, but it's 6.1 times 10 to the negative 3 kilogram day per milligram. All right, so once we know where we're going to need to find this chronic daily intake, once we get that, then we can put it into this equation. The chronic daily intake is the average daily dose divided by the body weight, and the average daily dose is the concentration of that chemical that you're taking in times your intake rate, or Q, we can call it here. We know this. We just found out it was 2 liters per day. We know the body weight for the average adult, and we don't know is this concentration. But once we get the CDI, we can solve for concentration. All right, let's solve for CDI. CDI is the risk, 1 in a million, divided by the potency factor, 6.1 times 10 to the negative third. CDI is then 1.64 times 10 to the negative fourth milligram per kilogram day. Next, we solve for that concentration, as we said. CDI equals concentration times body weight divided by intake rate. So we rearrange concentration, then equals CDI times body weight divided by the intake rate, Q. So that is 1.64 times 10 to the negative 4, what we just solved for, 70 kilogram adult, divided by 2 liters per day. And we get a concentration of 0.0057 milligrams per liter, which is the same as 5.7 micrograms per liter, or about 6 micrograms per liter. That's going to result in a 1 in a million risk of getting cancer from chloroform in drinking water.